Assalamu alaikum everyone. I hope that by the time you guys might have understood that an acceleration is essential to keep a particle following a circular path, obviously from my previous videos. But then from Newton's second law of motion, you might already have in your minds that in an inertial reference frame, every acceleration is caused by some force, and so should be the case with the particle following the circular path, which should have a value equal to the product of the centripetal acceleration and mass of the particle. This force is known as centripetal force. It is provided by tension in a string, gravity, attractive forces between the static charges, or magnetic field. It's not a new kind of force, but simply a force towards the center of the circular path. This is what it is when we look at it from an inertial reference frame. Now, if we look at the particle from the rotating reference frame, or better to say, from the particle's reference frame, we will see that an outward force is acting on the particle, and such a force is known as centrifugal force. It is equal to the magnitude of the centripetal force, just that it's working radially outwards, and centripetal force is required to counter that. So we can say that an object in a non-inertial reference frame accelerating at a0 will always have a pseudo-force of magnitude ma0 in the direction opposite to a0. Scientists wanted to exploit this effect to create artificial gravity by making the space stations rotate at an angular velocity such that m omega squared r equals mg, or simply centrifugal acceleration equals the gravitational acceleration that we experience on Earth. Though the concept has never made it out of the lab except for in movies like A Space Odyssey. For the real-life scenario, the concept is used to create multiple times of the gravitational force, or g-force, to train fighter plane pilots.